Alright, so we're playing with the central limit theorem, and two things that are important here are using a standard normal distribution calculator. We're going to use stat keys, and finding a critical z value, and that's the main thing we need to do now. So here we're going to estimate what % of people in the US put the cap back on the toothpaste after brushing their teeth. Out of 180 adults sampled, 68 put the cap back on the toothpaste. We want to do a 99% confidence interval for the proportion P of adults who put the cap back on the toothpaste. And we're given a standard error of 0.361. And typically we got that before from running a stat key bootstrap distribution of the proportion, the sample proportion. All right, let's take some notes on this sucker. So confidence interval. Confidence interval is always the sample statistic which for us is either going to be a mean or proportion. In this case it's a mean. And then we add and subtract from that sample statistic in the middle of the interval the margin of error. In this case we're going to call it the error bound on the proportion. And that is found by taking the critical z-score. Z-score comes from the confidence level, and multiplying that by the standard error. Right, so that's the new thing that we're doing in this chapter here. So we got to figure out what's the z-score to go with a 99% confidence level. And that you need a calculator that does standard normal stuff. You can use a spreadsheet for that, or stat key, or something else. So I'm going to go over to stat key. And in stat key, instead of using the single proportion confidence interval, which we could do, we'll double check with that, we're going to use the theoretical normal. And then we want to figure out what is the appropriate z-score. So here for 95% it would be 1.96. We want, for this particular one, a 99% confidence interval. 99% as a decimal is 99 hundredths. Alright, so this stat key tells me for a 99% confidence level, my z-score should be 2.576. So I'll make a note of that. Alright, so we got our z star here. That is 2.576. And next we need to multiply that by the standard error, which was given to us for this problem. 0.0361. Alright, so the product of these two is going to be our margin of error. So we whip out a calculator. Use Desmos here. So 2.576 times the 0.0361 gives me, let's go with 4 decimal places, 0.0930. So this tells me that from our point estimate, our sample statistic, the actual population proportion could be 9% greater than that or 9% less than that, somewhere in that region, somewhere in that interval. So I'm just going to make a little number line here for this. So in the middle here is going to be our point estimate, our p hat, which I believe in this problem was 68 out of 180. Let's check that. 68 out of 180. What is that as a decimal? That is about 38%. So we'll go with 4 decimal places again. So 3778. And the confidence interval again is plus or minus that sample statistic with the margin of error. So that means we could go whatever the margin of error is to the right, error bound on the proportion in this case, versus an error bound on a mean. So we might add that to get this number, which we'll do in a sec. And then we also subtract that from the sample proportion to get our lower bound. Calculator time. So from that, we're going to just do it as a rounded decimal, 3778, plus our margin of error, 0.0930. So we're going to get 4708. So it could be about 47% is the high for the proportion of people who put the cap back on the toothpaste. And for our low, subtract that margin of error, and we're going to get about 28.48% or 0.2848. So this is our confidence interval. And we state that in multiple different ways. We could state it as an interval. Sometimes we state it as the point estimate plus or minus the margin of error. Either of these represents a 99% confidence interval.